Okay, it is 9:01, so we're going to go ahead and get started. Good morning. Quick few housekeeping items. All attendees, please mute your lines during the presentation. We will be addressing questions at the end of this session, as we do have a fair amount of content to go through in half an hour. At the same time, feel free to submit questions online as well at any point, and we will address as well. My name is Brian Thomas, and on behalf of CED, Royal Wholesale, and CES, I want to thank you for attending this fourth session of our monthly application webinar series. The application we are discussing this morning is a legacy DCS migration and a specialty chemical batch project which provided a transition from a manual pilot to a production plant. This application discussion will be delivered by Wunderlich Malik, one of our preferred integration partners throughout California as well as the nation. At this point, the Wunderlich Malik team will introduce themselves and we'll get started.
Yeah, my name is Brian Philbin. I work out of the Phoenix office, and my team had implemented the two projects that we're going to discuss today.
And I'm Paul Sondrell from Wunderlich Malik. I'm located in the Calabasas, California office. I run business development and national marketing for Wunderlich Malik across the United States in our 22 offices. So, Brian, go ahead.
Okay, we're going to discuss three topics today, as Brian Thomas had indicated: a more APACS conversion, an LBSM project, and then a discussion about how we use simulation in our project implementations. Okay, so we want to talk a little bit, why was Rockwell Plant PX chosen for this conversion project? It was previously a more APACS system. More was acquired by Siemens. The plant had invested money in a conversion back in the 2011-2012 timeframe. Siemens subsequently announced that they were withdrawing support for the product, which caused dissatisfaction with the client. They were very familiar with Rockwell. There are quite a number of Rockwell PLCs of different vintages on the various subsystems around the plant. The maintenance people felt very comfortable. They were going in with looking at the PLCs and the other areas. So they felt very comfortable working with the Rockwell platforms. I had a very, very close relationship with the local distributor. We had previously implemented balanced plant systems in power generation. Some of the former employees from the client worked at one of our sites, so it was a very nice reference. And then probably one of the real key things is that we, working with Ken Nakamoto out of Phoenix office, demonstrated significantly reduced life cycle costs versus Siemens. This is very important to the client. So we basically tried to project out 10-year life cycle costs, and I think we were quite competitive compared to Siemens. A little bit of background: there's 5 GE LM6000 48 megawatt gas turbines. These are the aeroderivative type. There's actually 3 power blocks. One of the power blocks is a 3-drum heat recovery steam generator with steam turbine, which is pretty standard. What was a little different, though, is that there are 4 one-through steam generators for the other 4 jet engines, which go into 2 steam turbines. One-through generators have some advantages because you can run them dry compared to drum Persigs, and which have to bypass and things like that on. So it's quite a bit simpler. In terms of configuration, I'll show a network slide shortly. There were 3 redundant L75s, approximately 2,500 I/O between the 3 different power blocks. We had redundant factory talk, OPC, PDC, BDC, asset center. We had asset center in there to meet some of the NERC compliance requirements. We split all the servers in 2 different locations for disaster recovery, so that if there was a problem in one side of the plant, they could still run the other half of the plant from a remote location, approximately 1,200 feet away. One of our challenges was that we had a very narrow conversion window. We basically pulled all the APACS hardware out of the existing panels, put in the control Logix, and used IFMs. So we had to basically pull everything back and rewire it. And one of the challenges, for example, is that in an APACS system, you can have analog inputs and analog outputs on the same I/O card. So we had to pull back some of those wires and reroute them a little bit in order to follow the patterns that were available on the IFMs. One of the things is the plant PX objects, and we were at a 2.x release. We've since done a number of 3.x releases and soon to be 4.x release coming out in the first quarter. But the plant PX objects matched up very well with the more APACS objects. Basically, what we taught our engineers to do was when they recognized a certain pattern for some APACS objects, that there was an equivalent pattern that would be used for the plant PX objects. But in general, the plant PX objects have more functionality than the APACS objects have, and I'll talk a little bit about that when we get to some of the screenshots. One of the key things here is we used fairly extensively the plant PX steam tables, because when you have the one-through generators, basically you have to do everything at energy balance. So you have to calculate all the various enthalpies coming in and coming out to do basic energy balance to hold the steam temperature controls. Working with the OTSG vendor, we were able to increase the ramp rates, which resulted in a reduced time to bring the OTSGs and steam turbines online, which was an advantage to the client. As part of the project, we also installed a fiber ring around the whole plant, replacing the more APACS coax. This is kind of an overview display. There was a main ring that went around the plant that was a gigabit ring consisting of multi-mode and Cat5 connections. We interfaced all the various subsystems. When you see the red down there, FT network, that's our foreign device network. I'll bring a screen over. So basically that switch had fogging systems, sims, chillers, vacuum, gas turbines, steam turbines were connected into that switch. So we brought all the various vendor subsystems through our network and connected all their HMIs. So these computers up here are basically all the HMIs that were provided for the subsystems. The servers were placed over in what's called Power Block 3, which was at the end of the plant, and then the other servers and operator stations were placed in the main control room. At this time, there was not layering. This is all one big subnet. Any external connections, for example, they have a PI system that the client had. That was all brought through firewalls that were managed by the IT department of the client. The plant was subsequently acquired by another parent, and we're working on an upgrade right now to take the Plant PACS 2 to Plant PACS 3 dot. And at the same time, we're going to layer in some of the subsystems, adding firewalls between the plant network, if you will, and the subsystem networks. So that's in place right now. This is just an example of the steam table logic that was used. We had quite a number of steam tables that were used in the energy balance calculations for the one-throughs. Basically, each one of these was ×4. And this is just an example of the high-pressure feed water logic that had the steam tables embedded in them. This is basically an E-size drawing for function block. We had like about on the whole project, we had about 65 pages that all looked about like this. So there was extensive logic in the project. Talk about the screens a little bit. One of the things that we did was, in order to minimize the retraining for the operators, we made the Plant PX screens look very similar to the existing more APACS Wonderware screens with regard to pipe colors, pipe weights, how various devices such as a steam turbine over here, how they were presented. So the idea there was the operator would very easily be able to transfer over to operating on the Plant PX graphics from the graphics that were provided on the Wonderware system. One of the things that we didn't do is there's a trend in a lot of cases to go to ASM, abnormal situation management graphics, which makes extensive use of grays and blacks so that only abnormal conditions show up in color. These screens are actually have a fair amount of color in them. And one of the things we did, because you have 4 identical once-throughs, is we used a different background color to alert the operators to the fact which OTSG they were working on. And I'd say one of the differences that we had beyond what was provided by the more APACS is there's a very nice interface for handling permissives and interlocks where the operator can very quickly, if there's a condition that's keeping him from starting something, and very quickly determine what that cause is. And in many cases, it's something procedural that he himself could solve. We also made extensive use of the motor and valve statistics objects in Plant PX, which keeps track of how many starts, stops, how much runtime, how much the current runtime is. And these analytics can then be used by the maintenance people to, determine when they need to have work orders, when they need to do some preventative maintenance on their system. So that was a very nice feature that was not available in the previous system. Next, we'll talk about the LBSM project. This is a fast-track specialty chemical batch project. Basically, they were running in a manual pilot / small production plant, and they had increased their orders significantly, so they had to quickly go from a low production, basically manual operation to a automated operation. Again, we had a very good relationship with the local distributor. Wonderlic Malik demonstrated both process and electrical expertise. There were 4 reactors with associated front-end and back-end equipment. We also provided VFDs, motor control center from Rockwell. Rockwell shipped us a plate, back pan, if you will, for one of the FCC sections. We put all the PLCs and PLC hardware on that and then shipped it to the client site and then merged the back pan with the PLC hardware on it with the motor control center that had all the VFDs and fixed speed drives. One of the things we worked on was a proprietary interface to an analytical system, basically a spectrometer, that was very critical to the detection of the endpoint in the batch. This was how they made the product specifications that they were shooting for. And basically what they did is they quenched the reaction. So once the mass spectrometer gave them the answer they were looking for, they basically quenched the reaction, which allowed them to maintain these specifications on their product. We use the phase manager version of LBSM, and there were approximately 200 I/O on this project. There's a little bit of an overview display that kind of shows down here the various process areas. This equipment here was actually all mounted in one motor control center section. And then this shows the various servers and HMIs that were provided. Talk a little bit about simulation. We basically build simulation into our Plant PX objects. We believe that it significantly reduces our site startup time and cost. We're able to simulate the motors, valves, analog inputs. We've done psychometric data, basically using the steam tables, the PSAT calculation to create the psychometric data. All our PID loops are based upon parametric models, lead lag, gain bias, as opposed to first principle models. It's very rapid implementation because of the use of AOIs. And again, we do all kinds of fault insertion testing, like sequences and that, so that we can cause motors to fail, valves not to open, alarms, et cetera, which allows us to go through many more scenarios that we could ever test in a live plant scenario. And typically, we're not trying to make a flight simulator. We're making a simulation to test the control logic. So we typically run the analog simulation faster in real time to reduce our testing time. This is a shot of one of the sections of the simulation. This is a controller simulation. So this is the AOI that simulates the control loop. This IO is the interface point. This is the same interface point that's used by the physical hardware. I'll bring over another screen. This is a shot of the simulation for the...
Our callers. Thanks for giving us the opportunity to serve you. Please hold. We'll be with you shortly.
Yeah. But basically, and I'll just kind of go through it, there's 37, 38 rungs of simulation logic, many of which have 4 and 5 objects on them. So and we're able to build that very, very quickly by use of the AOIs. At this point, I'll turn over to Paul, and Paul can talk a little bit about Wunderlich Malik.
Okay, Brian, do you want to do that now, or do you want to have some questions on the application we just discussed first?
Yeah, I think what we'll do is open this up for questions real quickly, and probably take about 5 minutes or so to, if there's any specific application questions that anyone has at this point. So we'll go ahead and open that up. So, well, Brian Thomas here. If there's no questions, I'm going to ask one of my own. So kind of touching on what we just ended with the emphasis that you provided on the simulation, and of course the engineering effort that you invested initially to build up that functionality. You know, just from a general standpoint, how much time would you estimate on this job, what it saved from regards to billable engineering time to the customer, as well as reduced commissioning time?
Well, we're able to build simulation like that in a matter of a couple of days, so it doesn't take us that long. And the guys actually, as they're building the actual logic, they add in the AOIs for the simulators at the same time. So it's kind of done, it isn't done as a separate step, it's kind of done as part of the regular implementation. It allows us to check out things like alarm settings, or check the right logic, so that if we're in a sequence and the sequence hangs up, we can simulate what happens and make sure that our logic does the right thing. Because typically the forward logic in a sequence is pretty easy to implement. What's difficult is to figure out what the logic needs to be when things don't work the way they're supposed to. Well, it's fairly easy to cause those things to happen in simulation, but it's almost impossible to get the test time on a project to do that on a live physical plant. So we do this fault insertion testing that in some cases you can't even do in the field without simulation.
To add to that, Brian, I would say that one of our biggest risks as an integrator is the amount of startup time associated with the project, and we just cannot bid enough dollars in normal startup situations and remain competitive. So the ability to use simulation like Brian's created here significantly reduces our risk, and we can reduce startup time safely in our estimate, making us more competitive.
Okay. Excellent. Are there any other questions? All right. Well, I'm going to ask another one. On the APACS to the Plant PAX project, when was that completed?
Well, substantially completed in 2012. We've subsequently done smaller little projects, adding other subsystems in and making, various other changes. And then we have a pretty good-sized project right now to do the upgrade. They're doing a conversion to a new continuous emission monitoring system, changing what's called AGC, automatic generation controls. There's some changes there because of a new thing called the EIM, energy imbalance market, that the utilities are all bidding into right now. So that requires us to make some changes in the way that we do automatic generation control. So substantially complete in 2012, but we've been doing additional projects every year since then.
So when you look at that original project scope, do you have, and sometimes, the data is available for this sort of thing or not, but do you have any data on what the expected ROI or the reduced risk was that they were looking to achieve initially with the initial project and what they might have realized to date?
I don't think we put metrics in place for that. The metrics we worked on were the 10-year life cycle cost. Basically, the situation there is we had to get everything working like in about a 2-week period. I mean, one case we had to rewire like 1,700 I/O. So we had 6 guys working 18 hours a day trying to get all that done. So that was the big challenge because we had to go through and do 100% testing of all the field devices to make sure that everything was working properly. So it was a very, very intense 2-week period to try to get all that stuff cut across and bring the plant back up again. That was probably the most important thing, was to hit that narrow window.
Sure. Okay. Any other questions? All right, Paul, if you want to go ahead and jump in there.
Yeah, so many of you know who Wunderlich Malek is. We're a large system integrator, approaching $100 million in annual revenue. So most integrators in our space are in that $2 to $5 million range. We have a very strong relationship with CED and have a significant West Coast footprint with offices in Oregon and San Francisco, LA, Huntington Beach, Phoenix, Vegas, Albuquerque, and Denver. So a really nice footprint out here in the West, 22 offices nationally. We touch on almost all vertical markets due to our size, so power, oil and gas, food and beverage, water, wastewater, life sciences, theme parks, all of some very solid vertical market experience. We're an employee-owned company, which means it's wonderful for us, for Brian and I as owners of the business. We definitely see our stock price go up every year due to the efforts that we put in place. We have a very strong culture of maintaining our current staff and growing them, continuing education with RS Tech Ed and Automation Fair and Automation on the Move, shows that you guys sponsor, Lunch and Learns. We're constantly investing in our staff, and just trying to grow a little bit overseas in Latin America and China. One more thing in there, we are professional engineers, and we do have a general license in the state of California. We can bond projects north of 30 million. So really, there's no project that's too big for you to bring to us or too small to be working with us on. Our largest current project is $30 million over in New York, and we do smaller projects, in the $10,000 range as well. So 80% of our business is Rockwell, whether that's in the processors or in the software or in the drives or in the MCCs. We're familiar with every nook and cranny that is Rockwell. So we just recently received national certification for the System Integrator program. It's been a program that maybe we haven't invested as much time in it as we should have as a channel, just because we already knew Rockwell, so why would we invest in the channel? But we've changed our tune over the last year, and we're working with Mark Moriarty and Mark Jopru and the Rockwell team to help drive our relationship with Rockwell back in Milwaukee, and then back out through local distribution like you guys. So, Brian, you can pop on.
Yeah, this slide was put together just to show some of the different Rockwell technologies that we work with all the time. So certainly doesn't represent all of them. It gives you kind of a idea of the types of projects that we get involved with.
So anyway, Brian, with that, that's who Wunderlich Malek is. I don't know. We have a number of business unit managers that you guys probably deal with already, and Dieter Schultze and Bill Story up in San Francisco, and myself and Mike Thompson in LA, Brian Philbin and Jay Moore in Phoenix and Vegas, and Dave Lautner down in Huntington Beach. I welcome you guys to consider us on any projects you have coming your way. We do deal currently with a lot of the folks in, up and down the coast. So I'd like to thank Brian for the opportunity to let us present to you guys. And if there's any questions on Wunderlich Malek specific, I'd be happy to answer them, or just email me through Brian. That works as well.
Yeah, and just one real comment I'll make as well is Wunderlich Malek is a recognized systems integrator as far as Rockwell Automation is concerned. So there is a close partnership there that is between the two organizations. So thank you to the Wunderlich Malek team for presenting, and then for everybody that presented. If you would like to have additional discussions on this or related topics, feel free to reach out to the Wunderlich Malek team, or reach out to your CED, Royal Wholesale, or CSL representative, and we can discuss further. And if there are no additional questions, we will close out the session here in just a few moments. Looks like that's it. Thank you for attending, and have a good day.
Thank you.
Thank you.